All right, what we're going to cover is circles. Do have the test next week, the EOC test, and we're not going to, I know some of you are going to get in there and take it, and you're going to be really upset with me. Oh well, never had a student upset with me before. Because a lot of stuff that's on there, we're going to get to, but maybe not completely, and so hopefully just do the best you can. Some of the parts, copy down what you need to copy down on these notes as we go through it. First of all, the center point of a circle. That's the center point, and it's always labeled with some capital letter, ignore that. And when we name a circle, this is the symbol for a circle. It's just a little circle with a dot in it, and we name it with that one center point letter. So point or circle P. Hopefully most of you know what a radius of a circle is. Radius starts from the center point, and ignore that, goes to the outer edge. That would also be a radius in a circle. Something else you might write down with this, all radii, so any radius in that circle are congruent. So every single radii, no matter who draws the radius, they're all congruent to each other. They're all the same length. Diameter goes from the center of the circle, goes from one edge of the circle through the center of the circle to the other edge of the circle. Diameter is always 2 times the radius, so 2 times the radius equals the diameter, or half the diameter. Diameter divided by 2 equals the radius. A chord goes from one edge of the circle to the other edge of the circle. It's a segment that runs from one edge of the circle to the other edge of the circle. Does not have to go through the center point. When you're looking at a diameter and a chord, a diameter is a chord. A diameter is the longest chord. So diameter is a chord, but not all chords are diameters. Arcs in a circle, arc is part of the outer edge of the circle. So copy down what's in the boxes. A minor arc goes from one point on the circle to another point on the circle. A minor arc is always less than 180 degrees. So it's going to be less than half the circle. And that's something, if I go back over here, I should have put that on this first slide. A circle, one of the things that all of you probably know, circle is always 360 degrees. So all the way around here is always 360 degrees. That doesn't mean the distance, that's the measure in degrees. So minor arcs less than 180 degrees, less than half the circle. Whenever you name a minor arc, you just take the 2 endpoints and you name it arc P, Q, and you got to use the arc symbol. Make sure you make the arc symbol so that you can know that it's not a segment. We're not dealing with segment PQ. Segment PQ would run something like that, and that would be a chord. So minor arc PQ. A major arc is more than 180 degrees. And to name a major arc, use 3 letters in the circle. I'm going to erase a whole bunch of this. So if we wanted to name a major arc here, we might start at P, go through R, and go around to Q. That's more than 180 degrees. And to name that arc, we name it with the arc symbol still, P, R, Q. You name it with 3 letters, because if we just named it PQ, it might look like that arc right there, that minor arc. So it's PRQ going around this way. The other way we could name it with the arc symbol, QRP. So it's sort of like naming an angle. Just name this letter, that letter, that letter. Always use 3 letters for a major arc. 2 letters for a minor arc, 3 letters for a major arc. A semicircle. Semicircle is like half the circle. So a semicircle goes from here around to there. And the endpoints of a semicircle are always going to be the endpoints of a diameter of the circle. And the measure of that arc is always 180 degrees. Again, arcs are measured just like angles, so we use degrees to measure them. We could also measure a distance for an arc, and we're going to do that here in a few minutes. So we could measure a distance around the circle, but for now we're just using the degrees. Circumference of a circle. So now we're actually measuring the distance around the edge of the circle. The circumference of a circle, and we had this formula earlier this year, is pi times diameter, or it could also be 2 times radius times pi. Both those formulas mean the same thing. It's just one's using diameter, one's using radius. So that would be the actual distance. So if I started walking around this circle, I started walking there, and I walked around the circle, and I got back to right there, that's the distance I walked, not the degrees, the distance. Area of a circle, we had this formula earlier this year also, pi times radius squared. Do not get this confused with this formula. 2 different things, squaring the radius and timesing the radius by 2 different things. So area of the circle is telling us how much area fits inside the circle. Hopefully you remember those 2 formulas. The formula for a circle. The formula for a circle, last year you learned that this was the formula for a line. Y equals mx plus b. That's a linear equation. That's a formula for a line. Formula for a circle. So if you were to graph one of these formulas on your calculator, it would come out to be a circle. Is x minus h squared plus y minus k squared equals r squared. R is the radius. That one's pretty easy. The h and the k are the center point of the circle. So wherever the center point is of the circle on the graph, those are the numbers that go in for h and k. A lot of times we put our center point right at the point 0, 0. So the equation comes out looking just x squared plus y squared equals whatever r squared. Let's say r, for our purposes, r is 5. So r squared would be 25. So the equation just looks like that. If we have that equation, this is the example I'm doing here. If we have that equation, that tells us that the radius is whatever the square root of that number is, so the radius would be 5 in this case. And the center of the circle would be 0, 0. So if your equation looks something like that, let's do a different one. X squared plus y squared equals 9. We know our center for this circle is at 0, 0, and our radius is the square root of that number right there, which is just 3. The square root of 9 is 3. So don't make the formula for a circle all that real hard. X squared plus y squared equals 100. That means the radius is the square root of that, which is 10. And the center point of the circle is going to be at 0, 0. So if we were to graph this, center point's at 0, 0. We go out 10 here, out 10 this way, out 10 this way, out 10 this way, and we draw a circle. That's what our circle would look like. All right, stuff that we're going to use today. Fill in what you need to fill in on this. This is just some basic terminology. If you have a circle and you got a line that cuts through that circle, that's called a secant line. So it cuts through the circle, it hits the circle in 2 spots. It's called a secant line. You have a circle, and you have a line that touches the circle just at one point. That's called a tangent line. So a tangent line touches the circle at one point, secant line goes through the circle and touches it at 2 points. The point where that circle touches that line is called the point of tangency. Point of tangency. So if I take my yardstick and I lay it on my circle, where the yardstick touches the circle, if I laid it right there where that yardstick touches the circle, that's called the point of tangency. So secant line, tangent line, and point of tangency. And we're going to use those terms. An inscribed polygon, we talked about this a little bit earlier this year. Inscribed polygon, remember all the corners have to be on the circle, and the polygon, which this time I have a quadrilateral, is inside the circle. Remember, this is not an inscribed polygon. If all the corners aren't laying on the circle, then it's not inscribed. A circumscribed polygon means the circle's inside. So all the sides of the polygon, whether mine's a four-sided, just because that was easiest to draw, all of them touch the circle at one point. So each one of those is a tangent line to the circle. A sector of a circle is just like a piece of the pie. Sector of a circle has to be 2 radii. It's going out. They both have to go to the center point here. And it's that area right there. That's the sector of a circle. So it's like you're cutting out a piece of the pie. That certain section. Circles and angles, and this is mostly what we're going to do today. We're going to go over these. When you have these angles for circles, there's 3 different things that could happen. The vertex of the angle could be at the center point of the circle. The vertex of the angle could be inside the circle somewhere. Actually 4 different things. The vertex of the angle could be on the circle, and the vertex of the angle could be outside the circle. And those are the things that we're going to deal with. This first one, a central angle. Central angle has its vertex at the center. So that's what central tells you. The corner of the angle is at the center. Anytime you have that, the measure of this angle and the measure of this arc are the same. Remember, when we're talking about measure of an arc, then it's always in degrees. We're talking about the length of an arc, then it's in centimeters, millimeters, feet, whatever. So if this angle here is 50 degrees, then that means this arc is 50 degrees. That's for a central angle. So central angle, if the vertex is at the center, the angle and the arc are always the same. And you got to be able to pick out which arc. If I draw this central angle, notice that it cuts off, that angle cuts off part of the circle. That's the arc we're dealing with, the part that goes with the angle. An inscribed angle has its vertex on the circle. Notice here, if I have this inscribed angle, it cuts off this arc. The angle measure, so the measure of this angle right here, is always the arc divided by 2. So it's this arc divided by 2, that's going to give you the angle. Or, if we know the angle, we times it by 2, and that'll tell us the arc measure. So if I told you this arc was 100 degrees, we would take that and divide it by 2, and it's going to tell us that this angle is 50 degrees. If if I tell you that the angle here is 30 degrees, then I double that, and I would get that this arc is 60 degrees. So you just got to remember that the angle is half what the arc is, or the arc is double what the angle is. That's for an inscribed angle. The vertex of the circle, or of the angle, is on the circle. Inscribed polygon, circumscribed polygon, we already talked about that. I'm not sure why I put this on there twice. I don't know, did I put it on your notes? Yeah. So inscribed and circumscribed. I just didn't put the other ones. Yeah, they're both on there. Not sure why I put it on there twice. So just fill that in. Concentric circles are like a bullseye. Concentric circles all have the same center point. Mine doesn't look, it's not drawn very well, but they should all have the same center point. All right, now the part that we're actually going to do on the packet. Again, central angle, we just talked about this. Angle measure equals the arc measure. So whatever the measure of this angle is, has to be the same as the measure of this arc that it cuts off, the part of the circle that it cuts off. Angle and arc are the same. If the vertex is at the center point, that's always the case. Angle and arc are the same. So write both these things down in that little blank there. For a central angle, vertex is at the center, and the angle and the arc measures are the same. Remember, both these measures are always in degrees. Vertex on the circle. Two different ways an angle could look if the vertex is on the circle. Could look like this, or it could be an inscribed angle and look like this. The angle always equals the arc divided by 2. So if I tell you that this arc is 150 degrees, then to get this angle, we just divide that by 2. So that angle would have to be 75 degrees. If I tell you that this angle is 20 degrees, then this arc, the other way we could state that, is 2 times the angle as the arc. So 2 times 20 is going to equal the arc. So we know that this arc is 40 degrees. So vertex at the center point, angle and the arc are the same. Vertex on the circle, the angle is half as much as the arc, or the arc is twice the angle. Vertex inside the circle. The vertex is inside the circle. This is the key down here. This one's a little tougher, and the last 2 are a little tougher. Vertex inside the circle, you could have a chord angle, you could have a secant angle. Doesn't matter what you name them. If it looks like this, notice this time you have 2 arcs cut off. Well, these 2 angles are vertical angles, so they have to be congruent to each other. But these 2 arcs don't necessarily have to be congruent to each other. So what you got to do on this one is you take the 2 arcs, add them together, and divide that answer by 2, and that's going to give you the angle measure. So, and we'll find one of these on the packet here in a second and do it. So if I have a picture that looks like this is one of my arcs, this is the other arc. I know this arc is 100. This arc over here, maybe it's, I don't know, 80. I add those 2 arcs together, divide that answer by 2, and that's going to tell me what these angles are. And since those angles are congruent to each other because they're vertical angles, we only have to find one of them. So that's 160 divided by 2, which is 80. So this angle is 80 degrees. That angle is 80 degrees. Sorry. Thank you. I added wrong. 100 plus 80 is 180. That means each angle is 90 degrees. What happened when you get everything? Now, if I look at the packet, looking at the packet, I see, let's see if I can find an easy one here. Of course not, I can't find any right off. Yeah, oh well. Let's look at number 4. Number 4 has these kind of angles and arcs in them. Looks something like this. My picture might not be the greatest drawn. That's X, that's what we're looking for. We know this arc, I guess this one's all right. That arc is 55 degrees. This arc out here, the other arc that it cuts off is 175. So I'm just gonna add those two arcs together. Divide by 2. Try to make sure I don't add wrong this time. Let's see, that's a 230. And we're going to divide that by 2. That's 115. That means X right here, that angle is 115 degrees. That's our answer. This angle over here would also be 115. And if we wanted, we could then find this angle, because this angle and this angle have to be supplementary. So this angle's got to be 65 degrees. This angle's got to be 65 degrees. They didn't ask us to do all that. All they asked us to do was find that angle there. So if the vertex is inside the circle but not at the center point, it's inside the circle but not at the center, we add the two arcs and divide by 2. Some of them, when you have those kind of problems, are a little tougher. Trying to see if I can find one that's a little tougher. May not have put any on this packet. Doesn't look like it. Some of them are a little tougher. Maybe they tell you like this arc is 70 degrees, and maybe they tell you the angle is 30 degrees. Then what you'd have to do is you set up this formula, but it's going to say 70 plus, we don't know this arc out here, so that's going to be our X. So 70 plus X divided by 2 equals 30. And then you would have to solve that. And I didn't make up a very good problem because it's not going to solve out very well. But then you would just have to solve that equation. First thing you do is multiply both sides by 2, and then you would subtract off this number. Mine's not going to work because my answer comes up to be a negative, because I didn't make up a very good problem. Vertex on the circle again, same thing. Did I put this twice on your notes? So write this down for vertex on the circle. That's what goes in the blank. Same formula as an inscribed angle. Just looks different. So again, you take the arc and divide by 2. So if we know that this arc is, or let's do the angle this time. If we know this angle is 55 degrees, then to get this arc, all we do is double that. So 55 times 2, and we get 110. So that arc would be 110. And if you do that arc, you could find this arc also, because we know a whole circle is 360 degrees. So we could just take that and subtract off those 2. And that, so this arc out here would be 250. We don't have to know that. If all they're looking for is that other arc. But if the vertex is on the circle, it's the arc divided by 2 always equals the angle. Or, if we wanted to do it the other way, 2 times the angle has to equal the arc. We wrote that down before. vertex outside the circle. There's 3 different ways that the vertex outside the circle could look. It could be a tangent angle, where both these sides of the angle just touch the circle at that one spot. It could be a secant, where both of the sides of the angle are secants, they both run through the circle. Or it could be a secant tangent, where one of them is a tangent line, one of them is a secant line. For this, the formula is the same for all 3 of these. The angle measure, so whatever the angle is arc 1 minus arc 2 divided by 2. Arc 1 has to always be the bigger arc. Well, arc 1 is always going to be this arc that's out here on all of them, because that's going to be the bigger arc. Then arc 2 is always going to be the one that's closest to the vertex of the angle. For this one, they might tell you, just like this part, they might tell you that that's 100 degrees. Well, for this one, since it's a tangent angle, the distance from here to here, or I'm sorry, the measure from here to there is 100 degrees. Well, the whole circle has to be 360, so this part out here is just 360 minus 100, which is 260. And that's how you'll find that arc 1 out there. And then we would just do 260 minus 100 divided by 2. That's 130 divided by 2, which tells us that this angle right here would have to be 65 degrees. And we do the same thing on all of them. And again, these, they could be a little tougher because they could tell you one of the arcs and the angle, and then you have to put it in here in that form and then solve the equation. A quadrilateral inscribed in a circle, this is just a quick rule. Any quadrilateral, any 4-sided figure that's inscribed in a circle, you could draw it right now and make it look however you want it to look. If it's inscribed in a circle, the angles that are opposite each other have to add up to 180 degrees. They have to be supplementary. The angles opposite each other have to add up to 180. And it goes for these angles also. I just didn't draw it, so it would work for those 2 angles also. But opposite angles have to be supplementary. So just another rule for circles. And one more rule for circles, and you might put an asterisk beside this one. Triangle inscribed in a semicircle. So if that triangle is inscribed in a semicircle, that means that one of the sides of the triangle is a diameter of the circle. So a triangle has a diameter of the circle as a side. One of the sides of the triangle is the diameter of the circle. Anytime that happens, that angle has to be a right angle. So if you take a circle, you have a diameter, and you make a triangle out of it, no matter how you draw that triangle, it ends up being a right triangle. If I take that same circle and I draw something that looks like this, that has to be a right angle. Take that same circle, and I draw my diameter here, and I draw something like this, that has to be a right angle, every single time. So if the diameter of a circle is one of the sides of a triangle, then it has to be a right triangle. This is one of the key things about circles that gets used a lot. If we have a right triangle there, then that means we can use all the trig stuff that we've been doing, Pythagorean theorem, all that stuff works. Arc length and arc, so finding the length of an arc and finding the area of a sector. Instead of finding the arc measure, remember measure of an arc is always in degrees. So 50 degrees, 60 degrees, 75 degrees, whatever. Arc length is different. We're actually figuring out how much distance we travel. So if I start walking from this point and I walk to that point, what distance did I travel? Nothing really hard about this. To find the arc length, you just take diameter times pi times the arc measure. That's like 80 degrees, 70 degrees, whatever that arc measure is, divided by 360. So every time you're just going to take diameter times pi, you punch all this right into your calculator. Diameter times pi times the arc measure, hit equals, and then divide by 360, and it's going to tell you how long that arc is. So instead of saying it's 80 degrees, it's going to tell you that it's like 17.2 centimeters. So that's going to give you the arc length. To find the area of the piece of pie, so if we want to figure out what the area of that piece of the pie is, we do sort of the same thing. Just take pi times the radius squared, whatever the radius is, and we times that by the arc measure, which again is like 80 degrees, 70 degrees, 60 degrees, whatever it happens to be. Then hit divided by 360 on our calculator. And that's going to tell us how much area is in that piece of the pie. Don't make those two harder than they are. Not all that real difficult. Your calculator is doing most of the work for you. This is just a quick summary going back over the angles. The packet that you have is just dealing with the angles related to a circle. Vertex is at the center. The angle and the arc are the same. If the vertex is on the circle, then you take the arc, divide it by 2, and that'll tell you the angle. If the vertex, and I'm not sure why I switched these last two around, but it doesn't matter. If the vertex is outside the circle, you subtract the two arcs and divide by 2, and that'll give you the angle. If the vertex is inside the circle, but not at the center, not at center, then you add the two arcs and divide by 2, and that'll tell you the angle measure. So if you look at your packet, we're going to do a couple of these, try to do like one of each. If we do number 1, just look at it, and you see that the vertex this time, and I'm probably not going to draw all these pictures, trying to rush through this a little bit. We're looking for this angle, so we'll call it X. This arc is 50 degrees. This arc's 140 degrees. Vertex of this angle is outside the circle. So our formula is angle equals arc 1 minus arc 2. Oops, not squared. Arc 2 divided by 2. Angle is what we're looking for. That's our X. Arc 1 is always going to be the bigger arc. So 140 minus arc 2, which is this arc, 50. And we're going to divide that by 2. Do a little bit of math, 140 minus 50 is 90, then 90 divided by 2 is 45, so that angle, 45 degrees. Number 2, again, look at it, decide where the vertex is. This time the vertex is on the circle. They tell us that this arc is 144 degrees. The angle for this formula is just the arc divided by 2 if the vertex is on the circle. If it's an inscribed angle, the vertex is on the circle. So we just take the arc, which is 144, divided by 2, and you get 72 degrees. So that angle right there has to be 72 degrees. So vertex outside the circle, vertex on the circle. Let's do number 3. We already did number 4, where the vertex was inside the circle. But number 3, a little tougher, because they stick in some variables here. So this is 12x plus 8. This arc is 4x plus 4. And they tell us that the angle is 50 degrees down here. So again, angle equals arc 1 minus arc 2 divided by 2, because the vertex is outside the circle. Angle this time is 50. Arc 1 is 12x plus 8 minus arc 2 is 4x plus 4. All that divided by 2. First thing I'd probably do here, go ahead and multiply both sides by 2, get rid of this fraction. So that's 100 equals, and you could do this at the same time. You're doing 12x minus 4x and 8 minus 4. So 12x minus 4x is just 8x. 8 minus 4 is 4. And then we got an equation there that we can solve, add 4 to both sides, or I'm sorry, subtract 4 on both sides. We end up with 96 equals 8x. Divide by 8. You end up with x equals 12. So if x equals 12 and all they wanted you to find there was x. Number 6. They give us a picture, it looks like this. That's the center point. We have a triangle here. That's x. This arc out here is 70 degrees. Well, this angle doesn't really have anything to do with that arc. But this arc does have something to do with this angle. This is a central angle, its vertex is at the center, so this arc and that angle have to be the same. So if I split off that triangle, that angle right there has to be 70 degrees. This is a radius to the circle, that's a radius to the circle, so they have to be the same. So that triangle has to be isosceles, which means that these two angles have to be congruent. So if I just take 180 minus 70, that leaves me with 110. And if these two angles have to be congruent, I take that 110 and divide it by 2. So each one of them is 55 degrees. We were looking for that angle, so x equals 55. Some of them will be a little harder than others, just do your best.